Have you ever looked up at the sky and wondered, why is it blue? Or maybe you've been mesmerized by a rainbow after a storm and thought, how is that even possible? The world around us is full of incredible phenomena, and the answers often lie in the fascinating realm of science. In this video, we're going to embark on a journey to unlock the science behind some of these everyday wonders. From the sky above us to the ice beneath our feet, we'll uncover the principles that govern our world, and in doing so gain a deeper appreciation for the magic that surrounds us. Get ready to have your mind blown, because today we're turning the ordinary into the extraordinary. You know how sometimes you'll be just existing, going about your day, and then you see something that makes you stop and question everything? That's how I feel about the sky. I mean, it's blue. Why? What's happening up there? Well, imagine sunlight as this big, chaotic disco ball of different colors, all mixed. That light travels through space, and eventually it hits our atmosphere. Now, our atmosphere is made up of tiny particles like nitrogen and oxygen. When sunlight collides with these particles, it gets scattered in all sorts of directions. And here's the key. Blue light, because of its shorter wavelength, gets scattered way more than other colors. So when we look up at the sky, we're seeing all that scattered blue light reaching our eyes from every direction. Isn't that wild? The sky isn't actually blue itself, but the way light interacts with our atmosphere makes it appear that way. And speaking of illusions, have you ever noticed how the sky looks different at sunrise and sunset? It's often a beautiful mix of oranges, reds, and purples. That's because as the sun gets lower in the sky, the sunlight has to travel through more of the atmosphere to reach us. This means the blue light gets scattered even more, and the longer wavelengths of light, like orange and red, become more visible. So, next time you're looking up at the sky, take a moment to appreciate the incredible science happening right before your eyes. It's a reminder that even the most ordinary things can be extraordinary when we take the time to understand them. We've all been there, sitting on a plane, looking out the window at the clouds, and suddenly the existential dread hits. How is this giant metal bird defying gravity? The answer, my friends, is a beautiful dance of physics and engineering known as aerodynamics. It's all about manipulating the forces of lift, thrust, drag, and weight. Let's break it down. First up, lift. Picture the wings of an airplane. They're curved on top and flatter on the bottom, right? When the plane moves forward, air flows over and under these wings. Because of the curved shape, the air flowing over the top has to travel a longer distance than the air flowing underneath. This creates a difference in air pressure, with lower pressure on top of the wing and higher pressure below. And what happens when you have a difference in pressure? Things move from high pressure to low pressure. In this case, the higher pressure air under the wing pushes it upwards, creating lift. It's like the wings are constantly being pushed skyward, but lift alone isn't enough. We need thrust to counteract drag. Thrust is the force that propels the plane forward. This comes from the engines, which can be jet engines or propellers, depending on the type of plane. These engines create a powerful blast of air that pushes the plane through the air. Think of it like swimming. You use your arms and legs to create thrust and propel yourself through the water. Now, as the plane moves through the air, it encounters resistance, which we call drag. Drag is like the air trying to slow the plane down. Chapter 3. Rainbows. Not just for fairy tales, rainbows. Those magical arcs of color that paint the sky after a storm have captivated humans for centuries. But have you ever stopped to wonder what causes these ethereal displays of light? The answer lies in the fascinating interplay of sunlight and water droplets, a phenomenon known as light refraction, dispersion, and reflection. Imagine a beam of sunlight hitting a raindrop in the air. As the light enters the raindrop, it slows down and bends, or refracts because water is denser than air. This bending of light separates the white sunlight into its different wavelengths or colors. Remember that chaotic disco ball of light we talked about earlier? Well, each color of light has a slightly different wavelength, and they bend at slightly different angles. Red light, with the longest wavelength, bends the least, while violet light, with the shortest wavelength, bends the most. This separation of colors is called dispersion, and it's what gives the rainbow its distinct bands of color. But the light show doesn't stop there. After being dispersed, the light waves then hit the back surface of the raindrop. Some of the light passes through and continues on. but some of it is reflected internally, like a mirror bouncing the light back inside. This reflected light then travels back through the raindrop and exits out the front, once again being refracted as it passes from water back into the air. This second refraction further separates the colors, making them even more spread out and creating the arc shape we associate with rainbows. The angle at which the light exits the raindrop determines the color we see. Chapter 4. Hiccups. Why does our body betray us like this? Hic, hic. We've all been there, suddenly struck by an uncontrollable bout of hiccups, those annoying involuntary spasms that seem to come out of nowhere. But have you ever wondered what causes these strange bodily interruptions? Well, it turns out that hiccups are caused by involuntary contractions of the diaphragm, a dome-shaped muscle located at the bottom of our chest cavity that plays a crucial role in breathing. Think of your diaphragm like a bellows, pumping air in and out of your lungs. When we inhale, the diaphragm contracts and flattens, creating more space in the chest cavity for the lungs to expand and fill with air. When we exhale, the diaphragm relaxes and returns to its dome shape, pushing air out of the lungs. Hiccups occur when this normally smooth and rhythmic process gets disrupted. For reasons that are still not fully understood, the diaphragm can sometimes contract suddenly and involuntarily. This rapid contraction causes the vocal cords to close very briefly, resulting in the characteristic hic sound. It's like the diaphragm is trying to take a deep breath, but the vocal cords slam shut, creating that abrupt sound. So what triggers these diaphragm spasms? Well, a number of things can set them off, including eating too quickly or too much, drinking carbonated beverages, sudden temperature changes, or even stress and excitement. In most cases, hiccups are harmless and tend to go away on their own within a few minutes. However, in rare cases, persistent hiccups lasting for more than 48 hours can be a sign of an underlying medical condition and should be checked out by a doctor. While the exact purpose of hiccups remains a bit of a mystery, some scientists believe they may be a leftover reflex from our evolutionary ancestors. Chapter 5. Ice skating physics is your friend. Gliding effortlessly across the ice, feeling the wind in your face, it's no wonder ice skating is such a beloved pastime. But have you ever stopped to think about the science that makes this graceful activity possible? It all comes down to a fascinating interplay of pressure, friction, and a thin layer of liquid water that forms on the surface of ice. You might be surprised to learn that ice itself isn't inherently slippery. In fact, it's quite the opposite. The slipperiness of ice is due to a thin layer of liquid water that exists on its surface, even at temperatures well below freezing. This liquid layer is created by the pressure we exert on the ice when we stand or skate on it. Think about it. When you press down on ice with your skate blade, you're concentrating your weight over a very small area. This creates a lot of pressure on the ice, directly beneath the blade. This increase in pressure lowers the melting point of the ice, causing the top layer to melt and create a thin film of liquid water. This liquid layer acts like a lubricant, reducing the friction between the skate blade and the ice, allowing you to glide smoothly. It's like creating a miniature water slide right beneath your skates, but that's not all. The friction between the skate blade and the ice also generates a small amount of heat, which further contributes to the melting of the ice and the formation of the liquid layer. So, as you skate, you're constantly creating and replenishing this thin film of water, allowing you to maintain your glide. From the sky's blue hue to the physics of ice skating, we've explored some of the remarkable scientific phenomena that shape our everyday experiences. But our journey of discovery doesn't end here. The world is full of mysteries waiting to be unraveled, and by embracing our curiosity, we can continue to unlock the secrets of the universe around us. So the next time you encounter something that sparks your interest, don't just accept it at face value. Ask why. Dig deeper. Explore further.